This conference will now be recorded.
Good morning, friends. Welcome to goonlinetrainings.com. So, let us concentrate on data flow tasks today. So, data flow items today. So, data flow doesn't have any task. Data flow itself is a task. And we had discussed about sources, destinations, and everything already. Now, when you go back to your transformations, now all the transformation that you could see in the project, when you go to the data flow, you will be able to find out sources, destinations, and transformations. These are other transformations and these are common transformations. Okay, when you see them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Approximately, we have some 29 to 35, I think. Okay, there are some 35 transformations are available. Okay, so these transformations have been categorized into three. One is called block transformation. The second one is called partially block transformation. The next one is called non-block transformations. Am I clear? So we have some 30 to 35 transformations are available in our SSIS, and these have been categorized into three. One is called blocked, partially blocked, and non-block transformations. Let us understand what is the meaning of block transformation. I have a transformation called sorting. If you wanted to sort the data, you can use sort transformation. Okay. So now this sorts input data in ascending or descending order, eliminate duplicate rows, block transformation. It is a block transformation. Now, what do you mean by block transformation? Let us understand. These transformations cannot send a row onto the next transformations until all of the input rows have been read. These will degrade the performance of the data flow. Let me give you one simple example. I have a source. The source may be in India. So I'm reading the data from emp.txt file. Let us think like this. And the sort is happening in one machine in where SSIS is running. Clear? So let us think about the sorting is happening in the Dubai server. So it has to get the data, sort the data, and sending it to some other location. Maybe it is loading data to the Redmond of US. Clear? Reading the data from India and by a machine which is available in the Dubai, and all data it has to get it sorted and it has to send the data to the America. So this is what is happening now. Let us understand what are the operations in this. Simply sorting need to be done, but to sort the data, first read the data from the source. The second one is that sort the data. The third one is that load the data. Now, if I have 1 million data or if I have 10 million data here, can I take only one row and sort it? No. The sorting cannot happen on the one row or the 10 rows. So I have to load all 10 million data to my location. So wherever the server is available in this location, I have to load complete data. This server may be in India, this server may be in Dubai. So what happens in the Dubai server? You have to have enough cache. Cache means memory, RAM. So all 1 million data, if the file size is let us say 10 GB or 20 GB, if you don't have 20 GB of RAM here, then sorting cannot happen first because you need to have enough of RAM to take the data. So all the 4 GB of data, 10 GB of data, 20 GB of data has to happen here. Then after that, you supposed to sort the data. So that means what? Reading the data is one operation that may take 1 hour, 2 hours, 3 hours. We don't know. So during that time, sorting cannot happen. Sorting can happen once the first task is completed. Now sorting will take another 30 to 40 minutes because if you have 10 millions of data, 20 millions of data, sorting is not so very simple, right? So sorting will take another 20, 30 minutes. Then the loading will take another 10, 20 minutes. Now, if you see, all the activities are blocking each other. I am blocking you, you are blocking somebody else. So it is not sequential. It is one guy will take 2 days, then the second guy will start, then second guy will take 2 to 3 days time, then the third guy is going to be starting. So one operation is blocking the another operation, so which is going to be taking a lot of time. So if you take only the data and try to fully load to the destination without sorting, so what happens? You're not holding any data anywhere. Simply read the data, load the data, read the data, load the data. It may take 1 hour or 1 day, but when you have a sorting in between, it will become at least 3 times extra it is going to be taking. Clear? So when you have a large amount of data in the sources, sorting should not be used in between. Remember this point. Why? Because when you have a large amount of data, reading the data, keeping the data into the RAM, and again sorting will take a lot of time. So if you have something to be done immediately, or if you wanted to get good performance, you have to talk to your client first. So client may tell you, I need sorting operation to be done, but you need to educate the client saying that, sir, if we use the sort, it may take a lot of time. Is that okay for you? Okay, you need to tell them with the numbers. If you have 1 GB of data or a 10 GB of data, or if you have 1 TB of data, so what is the time it is going to be taking to sort it? So that you need to tell them that, and try to avoid them sorting in between. If you wanted to have sorting data, better keep the data in the source as a sorted data, or load the data to the destination, then try to sort it. But don't do in between if you having large amount of data. Clear? So sorting is also blocking a transformation is also called as a asynchronous transformation. Asynchronous means you have a gap in between these operations. For example, phone communication. I'm calling Padmaja and I'm asking her, how are you, Padmaja? Are you getting any calls, any interview calls? So she is replying me, sir, I have applied for job, but I'm not getting any calls. This communication is immediate. I am asking and she is answering. I'm asking, she is answering. This is what is called a synchronous communication. There is no delay anywhere. When there is no delay anywhere, that is what is called synchronous. But if there is a delay, that is what is called asynchronous. I send a mail to Padmaja or Bill saying that, hey, Bill, did you get any kind of a interviews or any interview scheduled last week? So Bill may be replying it today, may be replying tomorrow, may be replying after 1 hour or after 1 day. I don't know. So you can expect a delay from his communication. So email communication is called as a asynchronous communication. Asynchronous means there is a delay from one operation to another operation. I have sent a mail and reply may be immediate, may not be immediate, right? So if that is the case, that is what is called as asynchronous. Asynchronous means there is a delay in between. So here the first operation is going to be taking 2 hours, then only the sorting will happen. So 2 hours of delay. The sorting will take 30 minutes or 40 minutes. Then the load is going to be happening. One operation is blocking the another one. So this is what is called block transformations, or one operation is getting delayed by the another operation. So this is what is called asynchronous transformations. Clear? Blocking transformations are called as asynchronous transformations. Non-blocking transformations are called as synchronous transformations. Synchronous transformations, so all the activities are going to be happening without a delay. Let me tell you one more example. I have a conditional split, one more transformation. Let me go here. We were talking about sort, right? Now there is a conditional split transformation which is available as part of your common transformation. Now, what is this? Let us understand. I have some data here, 1A Chennai, 2B Hyderabad. I have some data. Now in SSIS, condition called city equals to CHN. Take the data, load it to the destination. Clear? Now what happens? It reads the data and apply condition. If the condition is a true, loads the data to the destination. So read, apply condition, load. You're not going to be blocking anything anywhere. It is what is called as a row transformation or called as a non-blocking transformation called as synchronous transformation. Read, do some action and load. You're not going to keep anything in the RAM or in the cache. Okay, so non-blocking transformation, synchronous transformation doesn't need any buffer, does not need any kind of a RAM space. Clear? Because you're not going to block anything anywhere. Read the data, do something, load it. Read second row, do something, load it. Read third row, do something and load it. So this is what is called row transformations. You can also call them as a non-blocking transformations, call them as a synchronous transformation. Synchronous means there is no delay in any operation. Read one row and apply condition immediately. If the condition is true, then load it. If the condition is false, then leave the row. Then read next row. So like that, it is going to be happening row by row, row by row. So these are called non-blocking transformations. These are very, very fast. Clear? So tips for sort. Avoid sorting operation during the data flow for the large amount of data. If necessary, use sort transformation for smaller size data. When the data size is large, perform the sort operation prior to the data flow or after the data flow is done. When the data is arrived to the destination, you can sort the data in the destination and you try to, store them permanently, but not in between. You always concentrate on loading the data first. Get the data, load the data, then you can do any operation if you wanted to perform that can be performed on the after loading the data. Clear? Especially for the sorting or we have few transformation which are blocked. Now, what are the blocking transformations that SSIS has? Aggregate, fuzzy grouping, fuzzy lookup, sort, and merge. Out of 35 transformations, these are called blocking transformations. You should use them sparingly, not heavily, not everywhere. If you use them automatically, the performance will get decreased. So tomorrow people will definitely, the client will not be happy about your application. Clear? So blocking is very, very dangerous. It's going to be taking a lot of time when you have large amount of data coming from the source to the destinations. Partially blocking transformations are data mining, merge join, pivot and pivot, term extraction, term lookup, union all of them. And we have non-blocking transformation, audit, character map, condition split, copy column, data conversion, derived column, import column, lookup, multicast, percentage sampling, row count, row sampling, script component. All these are called non-blocking transformations. So you can use them without any pain, any problem. So these are very, very fast. Okay. This is a compulsory in interview question. Synchronous versus asynchronous, or people will be asking, road transformation, or people will be asking you non-blocking versus block. These process a row by row. These process a block or chunk of rows or set of rows. No buffer, hence it has to interact with the external source as a buffer. All the data is kept in the cache or in the buffer. On that, it's going to be doing its activity. These do not keep data anywhere. These are faster. These accumulate the data in the buffer or the RAM. These are very, very slow. Example is data conversion, condition split, transformation, sort, merge, aggregate transformations are asynchronous, called as a block transformations. Clear? It's a very, very important interview question. Now, this is what we discussed. Now, let me talk about some more things. What are the common transformations that we have? Okay, so the first transformation is called aggregate transformations. When you go here and you see in the common transformation, you should see an aggregate transformation. What is the meaning of this? And where exactly we're going to be using aggregate transformation? Let us understand. Can use average, sum, min, max count on the source data, supports group by clause, block transformation. It is also very slow. I have source data like this. but the destination does not need the data as it is. They wanted to know how many customers are there in this city, that numbers they need it. Employees, okay? How many employees are there in this city, in this city, in this city? Only this count they wanted to have it. They don't need the source data as it is to be copied to the destination. I would like to apply aggregated transformation in between and send the aggregated data to the destination. If that is the purpose, I'm going to be using aggregate transformation. Sometimes you may have, city-wise collections. Okay. So what they need is that they don't need city-wise daily collections. So day one, day two, day three, day four, you have daily collections in the city. So they accumulate city-wise monthly collections, and you will be able to send city-wise monthly collections. So daily collections will be aggregated into monthly, and the data you will be able to sending it to the destination table. Clear? In that purpose, we're going to be using aggregate transformation. So balanced data distributor distributes data to many destinations, faster insights to destinations. It is for the load balance, round robin technique to store the data. So now sometimes what happens is that we will be able to get lot amount of data coming from the source. Clear? So you are reading one large file here. So large data file you are reading, and all the data, large sales data you have. Okay, it is having millions, billions of rows. If you wanted to take source data and trying to load to one destination, and it is very, very slow. You can load it, but what happens is that you will be, loading with one to one. So instead of like that, what Microsoft says is that you never load like this. It will take a lot of time. You better use balanced data distributor. What happens is that it is going to be a balanced data distributor. You need to configure balanced, right? Data distributor. Let us use it. Now it is going to be distributing the data. It is going to be distributing the data to different tables and different things. Okay. So some of the data will come here, some of the data will come here, some of the data will come here, some of the data will come here. For example, what happens is that if you have 1,000 million data, let us think about you have 100 rows. Okay. When you have 100 rows, what happens is it is going to be giving one row to this. One row, some of the row will come. The first row will go here. The second row is going to go here. The third row is going to go here. The fourth row is going to go here. Again, the fifth row will go. Sixth row will go. Seventh row will go. Eighth row will go. Ninth, 10th, 11th, 12th. Okay. This is how it is going to be distributing the data to different destinations. Because if I give complete data to you, for example, you think I'm getting you 10 bags, and a 10 bags I'm trying to give it to you, and you're supposed to take the 10 bags and load it to a storeroom. What happens? Can you carry all 10 bags? It is impossible. So I'm getting you 10 bags. I'll give you one bag, and I'll give the second bag to one more guy. I'll give the third bag to one more guy, and I'll give the fourth bag to one more guy. So one guy will go keep the bag in the storeroom, and he will come back and give the fifth bag, and again he will go. By the time he's going, the next guy is going to coming, he's ready, he will take the next row, like that. So you are not blocking only one guy. So one guy is taking 100,000 rows and inserting into the hard disk is very, very difficult. Instead of that, you parallelly distribute the workload and try to load the data into the destination tables. Clear? So this is a very, very important thing. So if you wanted to, distribute the data and store the data into the storeroom, definitely you need to have four, threads or four processors. You can split it, and you should be able to run this package, because we know that nowadays the computers are coming up with the parallel processing and multi-threading once upon a time. Now it is multi-processors, because when you buy i3, i4, i5 applications, i7 processors, it is not only single processor, it is having 6 to 7 processors in your computer. Clear? So it is going to be getting the data, and from one processor is loading the data into one hard disk. And here a hard disk also should be able to write the data very fastly in your in your hard disk. Now what happens in the big servers, they don't buy only single hard disk. For example, I have only one hard disk. One hard disk will have only one header and one reader. Clear? So what happens if you read 100 million data to one hard disk? It has to write all the 100 million data by one hard disk, one header, one reader only. So what happens, instead of having, if you have multiple hard disks, if you have multiple hard disks, then what happens is that you should be able to, you know, you should be able to load the data simultaneously. One hard disk is writing the data into this, at the same time second hard disk is also writing the data here, third hard disk is also writing the data here, fourth hard disk also writing the data here. So big servers will not have a single server or single hard disk, or it is not going to be having a single RAM, or it is not going to be having a single processor. Clear? So everything is they will have a parallel processors are running, parallel hard disks are running, so they will be able to store the data in a couple of hard disks simultaneously. However you create your database. For example, I create a database like this. Now if you see carefully, if you go to the properties tab, you will have files and file groups. Clear? So if you know, beautiful concept here, Microsoft neatly organized. They're telling that we have only one ibank database. Okay, but one ibank database, I have one table. Let us think this is one table, or let us take one Amazon data warehouse. Okay, I have a table. Let us think a real-time situation, a fact sales table I have. Every time I am getting 100 million data. Okay, so now where the table data is getting stored in the data, where in the database, we know that any database is not going to store the data in the tables. So storing the data in a table is a myth. So actual data is going to be stored in a file. So where is the file? When you go to properties, when you go to file, and you can see that it is created two files. One is called log file, one more is called mdf file. So in this file, complete data, dimension table data, factor table data, whatever be the table, x table, y table data, it is going to go here. So that means end of the day, you think that data is going to the tables, but indirectly, or a SQL server is not going to store the data in the tables. Tables are logical entity. Physically, the data is being organized in the files only. That's what you need to understand. When you go, so what a good DBA should do, or what a good developer should do, they need to create a multiple files. One file in hard disk number one. One more file. You can create one more file now. You can create one more file. Let me create a file. Okay, if I create a file called Amazon data file, so that I am going to be keeping into one more drive. So now one more hard disk. So I have a C drive, it is one hard disk. I have one more D drive. So this is what I would like to keep the second drive. Clear? Like that I can have Amazon data 2. Okay, so this I would like to have it here, this I would like to have it in some other drive, like that. So now you think, when you give the data, when you give the data to this fellow, when you're dumping the data, do you think that all the data is going to go to one hard disk? No. So what happens is that when you go here, go to the properties, now when you see the files, so if you're storing 100 rows, some of the data is going to go to C drive, some of the data is going to go to E drive, and some of the data going to go to D drive. It's going to be creating a file called NDF file. So these files are storing the data. That means what? All these tables data in Amazon.com, it is not only single file, and this data is distributed in different hard disks. Some of the data in C drive, some of the data in D drive, some of the data in E drive, some of the data in this drive. For example, if you have 1 million data here, one third data will be there in C drive, one third data will be there in E drive, F drive, something like this. It is not going to be one minute, guys. Somebody is calling this. Come.
This conference will now be recorded.
Okay. So when you create like this, whenever you store the data into the tables, what happens is that simultaneously, which is going to be writing into the different hard disks altogether. Okay. So like this, you should be able to distribute the data. And like that, when you have a balanced data distributor also, which is going to be getting the data from, a bigger file, and when you give the data to the different uh, tables, now each table is going to be loading the data to the different partitions, but you need to properly you know uh, create the database. Many people will not think about these files and file groups, but if you create proper files and file groups, simultaneous reads can happen, simultaneous writes can happen. There's a big architecture that you need to understand, why the files are available, while the file groups are available, how can we where can we put the data, so what kind of a data can be kept where. So these kind of a things that you should be aware of. But even though you don't know this, but still you should be able to use balanced data distributor, so which is going to be splitting the data. For example, you have table 1 sales data, you're getting it, you can create table 1 data, table 2 data, table 3, table 4, four tables you can create, and you can parallelly dump the data into four tables. Later you should be able to merge all this data into single table. At least loading will not take any time. Clear? So that is what is called balanced data distributor, which is going to be using a technique called round robin technique. It is going to be using a technique called round robin technique. What is the meaning of that? The first row will go, second row will go, third row will go, fourth row will go, fifth row will go to the this one. Again, sixth, seventh, eighth, ninth, 10th, 11th, 12th, like that. It is going to be happening like that. This is what is called round robin technique. Even SQL Server is also, when you create lot of files here, when you go when you create a lot of files here, so you have C drive, D drive, E drive. When you store large amount of data in any one of these tables, all the data is not going to go to one drive, it is also going to use round robin technique. So some of the data will go to file number 1, second row will go to file number 2, file number 3, file number 4. Like that the data is going to happen. So round robin technique is going to be happening in this databases also if you have multiple files within this. But normally people will simply create a Amazon database and they never think about anything here. Okay, so simply created data a base, and when you open the properties, they will be having only one file. See, they will be having only one file always. By default, it will go to one drive. So you cannot achieve a parallel inserts, parallel updates. And if you have a large amount of data, this database cannot give you definitely much more performance. When you are keeping a multiple files into multiple hard disks, whenever you're joining the tables, whenever you're reading the data, not only one hard disk, right? Because some of the data, one third data or one by fourth data is available in this, one by fourth in this, one by fourth in this, one by fourth in this. Now, if you need complete data, four hard disks are reading data, and you will be able to get the data very quickly instead of all the data read by single hard disk. All the data read by single, hard disk. Reading and writing will be happening parallelly, by parallel processors, parallel hardware. So this is how the actual servers are configured. Servers are deployed in the real time. So they'll have 1 million data is not going to go to one hard disk. 1 by 4th data will go to one hard disk. 1 by 4th data will go to one hard disk, and different files are placed differently. Clear? So that even though there is a corruption happens, complete data will not get corrupted. Only one hard disk data will get corrupted. That means what? 1 by 4th data only they're losing. That is, they can anytime get it back. Not complete, four hard drives. Clear? If you store everything in a single thing, if you lose that, then complete data is gone. Even though you're losing one hard disk is failed, what happens? Remaining three hard disks is having 75% of the data. So recovering 25% of the data will take lesser time instead of recovering 1 terabyte of data that is stored in a single hard disk. Clear? So that's how the machines are organized in the real time. Even SQL Server also is doing same kind of a technique, round robin technique. Clear? If you have multiple files, multiple tables, you store this multiple files in multiple file groups into different storage devices, so that you can get a better what is called as performance. So for that purpose, normally we're going to be using round robin technique plus with the balanced data distributed transformation. Clear? And here remember, not only the software but also hardware. Okay, you cannot say that I can have only one hard disk and I would like to have very good uh, writing faster. You will not be able to achieve. Instead of that, you buy a smaller hard disks more. For example, 1 terabyte of hard disk or two terabyte of hard disk, you buy at least 3 4. So server will be having like that. And when you store the data, four hard disks can get the data at a time, and they're going to be writing into its locations. And if you wanted to read the data back, again, four hard disks are going to be reading the data at a time. So that whenever you join two tables, for example, employee table and a department table, you would like to join. So the better thing is that in hard disk number one and two, you place employee table. Hard disk number 3 and 4, you place department table. So when you join employee and department table, four hard disks are writing at a time and giving the data, and this is very fast. But if you're putting employee and a department table into single hard disk, so single hard disk has to get the employee data, the same hard disk has to get the department data. Joinings are not very faster. At the same time, when you're loading data into employee table, when you're loading into data into department table, all the data you're writing into a single hard disk. Now single hard disk has to insert the data of employee, then insert the data of department. Instead of one hard disk or two hard disks for employee table, two to three hard disks for the department table, when you separate the tables like this, and whenever you're joining the tables, which are very faster because all the data not coming from the single hard disk. So those things you should be aware whenever you learn. So SQL Server. So those concepts also very important. Clear? Many people do not know about that. So the next one is called cache transformation. When you go here, the next one is cache transformation. So we'll talk about condition split. There is a cache transformation. Where is that? I think that is from the other transformation I have taken. Yeah. Now, this will cache the data from the source to speed up the process. The lookup transformation performs the lookups on the cached data. Caching means you can understand something, some data which is there in the RAM. Caching, buffering, RAM, memory, all of them refers to your primary memory only. Clear? If you keep something in the RAM, what is the advantage? Advantage is faster. If you have something in the hard disk, that is permanent, but it is slow. So database technology is completely disk-based technology. What is the meaning of this? I told you, whenever you store any data in an Amazon database, so first you should know it is not stored in a table. Tables are logical. Any database, RDBMS stands for Relational Database Management System. RDBMS is not a storing system. RDBMS is not a data storing system. So people will pay, it is storing, it is not really storing the data. It is only managing the data. Data will be stored by the files and file groups only. You take Oracle, you take NetEase, any RDBMS is not going to store your data in tables. Clear? You should know that first, because RDBMS stands for Relational Database Management System. It is not storing your data physically. All of them are logical only. All the data is going to go to where? Your hard disk. So RDBMS is completely disk-based technology. It is not going to store the data in the RAM. If you keep some data in the RAM, when you shut down the computer, the RAM data is gone. So it is a permanent. You read the data today, you read the data tomorrow, it is available. You insert the data today, it is there. If you update the data tomorrow, it will be there forever. After 1,000 years also, it will be there. Since the data based technology is storing the data into the hard disk with the help of a file. Clear? So that's what you should know. When I'm saying a cache, some data you're going to be dumping into the RAM. So when you keep something in the RAM, what happens? It is very, very faster to access. Clear? So that's what is cached. This cache I'm going to be using in the lookup transformation. Now many people would heard about HANA technology, right? So SAP HANA, it is also one more BA tool, right? SAP HANA, right? So SAP HANA is completely a RAM-based technology. What is the meaning of this? All the data, all the aggregations are kept in the RAM. When you keep something in the RAM, which is 1,000 times faster than the other technologies. When you have SAP data, I would like to aggregate and keep the data back to the hard disk. If you have some data in the hard disk, you have to bring it to the RAM and do something on it. But now HANA is created based on the completely, it is RAM oriented technology or memory based technology. Okay. So like that, Microsoft is also build a tabular model, right? So when we're talking about SSIS tabular model, SSIS has two models. So we'll discuss later, multi-dimensional model, multi-dimensional model, and it has a tabular model. So it is going to be keeping the data in the hard disk. So which is going to be keeping the data into your RAM. So which is very, very fast. But RAM has a problem of space because RAM cannot be 2 terabytes, the 1,000 terabytes. Limited data can be stored, but which is very, very faster. So tabular model is a RAM based. Why people are going to be storing some data into the RAM? Because they would like to get the faster response. Like cache transformation also we can use to get the fast response at the time of using lookup transformation. We'll discuss lookup and we'll discuss about cache transformation once again. The next one is called conditional split. Splits the input data based on filter condition. So I wanted to split the data. Say gender male data should go to one destination, gender female data should go to another destination, remaining data should go to unmatched destination. Like that, I can split the data based on its condition. It is equivalent to where clause of a RDBMS, where city equals to something, where country equals to US. I can write where clause, right? So where clause you can write in the RDBMS tools. But if you're getting data from flat file, can you write a where clause? Because a flat file cannot understand a where clause. That is when you need to write conditional split. If the data is available in SQL Server Oracle, you can say select star from employee where country equals to US. You can write where clause, filter the data, or where country equals to America, or where the country equals to Japan. You can apply a where clause. If the source is a flat file or Excel or XML, you will not be able to apply a where clause and filter the data. That is when I need to use conditional split transformation. It is equivalent to applying a where clause. Clear? Now, I have some data, employee ID, name, salary, gender, department ID. Now, I want to get male data should go to one destination. Female data should go to one more destination. I have a wrong gender is inserted here, KD, right? So male data here, female data here, unmatched data, K and D is unmatched data. These two rows are going to go to unmatched destination. Clear? Because this will be going to go here. So you can split the data based on multiple conditions. Male data here, female data here, and unmatched data can go here. So you can write multiple condition and you should be able to store the data into different places. That is what is called conditional split transformation. We will be doing demos on that. Split the data based on the year. So I have the date of purchase, product ID, product name, date of purchase. I would like to store 2011 data into one table, 2012 data into one more table, maybe available in one more server, 2013 data into one more server in one more table. I would like to split the data based on the year and send it to multiple servers and multiple tables. If that is the case, go in for the conditional split transformation. You can apply on any column. Now the next one is called data conversion transformation. Clear? So we have basically two categories of data is available in this world. Clear? So if you take data or if you take a characters, data is represented in the characters only, right? So the data in the characters is divided into two categories. One is called Unicode data, okay, or Unicode characters. The second one is called non-Unicode characters. We have a vegetarian, we have a non-vegetarian. Like that, we have a Unicode, we have a non-Unicode. What is the meaning of a Unicode? Let us understand. And what is the meaning of non-Unicode also? Let us understand. Non-Unicode means the character data, the data it is available only in English, nothing else. So whatever you store, that is in English. For example, I am opening my notepad, I am writing, it is simply in English. Okay, this data is called as a, I am storing some employee data like this, right? So this is purely English data. This is what is called non-Unicode data. Unicode data means it is all languages. It includes English. Remember this. It is not excluding English. It is including English. So this is all Unicode data. So I wanted to store my data in my own language. You would like to store your data in a computer in own language. If you go to China, they don't use English. If you go to Gulf countries, they don't use the English. They use Arabic and their own preferred languages. Clear? So in India we use much English, but some other countries may use English. But lot of countries they don't understand English. So that is when the applications are developed in Unicode only, and the data is also stored in the Unicode only, not in the non-Unicode format. Even if you open a Google Gmail, you can see a lot of them in the Unicode format. That means, so complete search can happen in the Unicode format only, right? That's what you should know. For example, I'm talking about this is completely Indian languages. Whatever you're seeing here, it is what is called Unicode data, Unicode characters. Okay, that's what you need to understand. So Google, Gmail, Java, .NET, Oracle, XML, XYZ, Android, everybody has to accept Unicode today. Why? If you say that I can support only English, people will throw you out. People will throw you out. You lose your business. Clear? So many countries needs their own language to be implemented. So all applications, Java, .NET, any language, any bloody technology that you're talking today, that must allow Unicode character set. That means it has to support completely English plus other languages as well. Clear? So that's what you need to understand. Now let me go back and see here. So that is one point you need to understand. The second point, Unicode and non-Unicode, is each character will take only 1 byte. So here, each character will take only 1 byte of space. Here, each character will take 2 bytes of space. For example, I store Anu. Anu means here 1 plus 1 plus 1, 3 characters, 3 bytes. The same Adu 2 plus 2 plus 2, I'm going to be having 6 bytes. Here I'm going to be having 3 bytes. Even though I'm storing in English here, even though I am also using English here, since it is a unique code, it is going to be having this one. Clear? So Microsoft SQL Server. So if you open SQL Server, you have a few data types for this. This is what is called nchar, nchar, and nvarchar. So these are the two data types are available in SQL Server. National char, national varchar. This side, Microsoft is using, SQL Server is using. So we have character data and we have a varchar data. So these are the data types SQL Server is going to be using, or you may have a text. So this side we have n text. So all these are the different data types that Microsoft is using. N text, N stands for national text. Now SSIS also using. So SSIS data types also available. For the Unicode we have DT WSTR. This is the data type. Okay. So this side we have SSIS is using DTSTR. Okay. So DTSTR means non-Unicode data. DTWSTR means it is Unicode data. It supports all languages, including English. Clear? So W stands for wide string because it's going to be taking 2 bytes for each character. So DTWSTR means DT wide string, DT string. String means char, var, char text data. So SSIS data type is this. SQL Server data types are this. Okay, SSIS Unicode data type is DTWSTR. So this data is this. Clear? So you need to understand some of the applications today. For example, let us talk about Excel. Excel is today unique code. It is going to be support all languages or XML, right? So you take any JSON. If you take these latest technologies, all of them are going to be supporting a unique code. But some technologies like flat file or CSV files today, they are not supporting unique code data. That means this data is always DTSTR data. But if you take the flat file data and you try to dump it to Excel, so it cannot go directly. Why? Because the flat file data is DTSTR data, Excel data is DTSTR data. Clear? So flat file today, it is completely string data. It is non-Unicode data, supports only English. But now some of the new applications, Excel, XML, JSON files are going to support this kind of a data. You cannot take flat file data directly. You cannot dump into Excel, or you cannot take Excel data directly dump into flat file as well. Okay. So if you have this data, you have to convert into this. If you have this data, you have to convert into this. So this is the purpose we're going to be using data conversion transformation. Clear? So I told you Notepad text files are completely non-Unicode data. It is localized. Only one place people can only read. All over the world, these cannot read because English is not the universal language. Right? Not necessary that everybody should know English. So people will have their own languages. Clear? So Excel data you cannot directly dump into Notepad. Notepad data you cannot dump into Excel. It is going to be failing. So because it is a DTSTR data to be converted to DTWSTR. So that purpose we're going to be using data conversion transformation. This converts data from one type to another, can apply multiple conversions to a single input column. Clear? So we're going to be using a couple of demos tomorrow so that you would understand. Derived column transformation. The purpose is to have the complex expressions. This creates a new column by using existing columns. It can add a new column or replace an existing column. Example is that take only first letter from the gender. So source is having a female, but in the destination, I wanted to have only the first letter. So I would like to apply some kind of an expression, get the data. If the gender equals to male, then the destination must have Mr. Dot name. If the gender equals to female in the source, the destination table should have miss dot the employee name or the customer name. Or I wanted to trim the strings. So whatever you wanted to do, I would like to apply some kind of an expressions on the existing data. So that is when we're going to be using derived column transformation. Let me give you a couple of examples I have given you. So now if the gender equals to male, I should be able to get the Mr. dot name. So how do you write this kind of an expressions? So there is a C language expression can be used in the SSIS. If the condition is true, action 1 is carried out, else action 2 is carried out. Gender equals to male, Mr. concatenating the name, else Miss concatenating the name. So this kind of an expressions are allowed. So we're going to be using in tomorrow's class. And I have a data like this. Whenever I would like to dump it, I would like to have Mr. and Miss to be, you know, prefixed to the name column. Mr. Ram, Mr. Kiran, Miss Anu, Mr. Raj, Miss Lata, so Mr. Naveen, Mr. Anil, like that. I wanted to have the data like this. If you wanted to have, then apply a derived column transformation in between, so you transform the data. So Ram will become Mr. Ram. Kiran will become Mr. Kiran. So that is what is called transformation. You apply something, you change something to the data and load the data to the destinations. Okay, this is the expression that we can write. So we will be doing the demo in tomorrow's class. I have a something here. I wanted to split the name as well. Bhaskar is the first name, Jogi is the last name. So the full name I have it in the table. In the destination I need to split the data and store like this: Bhaskar, Jogi, Durga Soft, Surya Prakash, whatever you wanted to have. I would like to split first name into last name, first name and last name, from the full name. Or you may get the first name, last name, and convert into full name. So whatever you wanted to do, you have to write an expression. The expressions can be written in the derived column transformation. I cannot see a project or a package without having a data conversion, without having a derived column transformation. You can understand every package, every project will have thousands of derived columns and lots of data conversions. Clear? So these are heavily used transformations in your projects. Everywhere we write the expressions, everywhere we have to convert the data, right? So to get the first name, this is the operation I have to do it. To get the last name, this is the string operation that I have to use it. So this we'll discuss tomorrow. These are very, very simple, not very complex to understand. This is very, very simple. Even 10th class failure guy also can understand these expressions, not very complex. Even though you failed 10 times in 10th class, you can understand. These are very, very easy. So I'll make you easy. Clear? So the next one is that I would like to convert the source data into uppercase and lowercase. Okay. So on that, on the source data, I would like to apply these kind of things. Then go in for character map transformation. You can add as a new column or replace an existing column. So take the data, convert there itself. Uppercase, you make it there, or you copy the data, create a new column, and new column data, you make it as uppercase. Original data, you don't touch it. So that is replacing an existing or add as a new column. So create a new column from the existing column and you apply uppercase, lowercase on the new column data. So this is character map transformation. Then multicast transformation. It distributes the input data into one or more outputs. I have some data here. So all people have to get the same data. One input, many outputs. If I have 1,000 million data, Excel will have 1,000 million data, XML will have 1,000 million data, Oracle also will have 1,000 million data. All the data is going to go to all places. One input, multiple outputs. So all data will go to all outputs. Same number of rows go everywhere. If you have 10 rows here, 10 rows, same 10 rows and same 10 rows will go here. So multiple copies will be available in multiple destinations with the help of multicast transformation. It distributes its input into one or more outputs, does not have any properties to set. Simply copy and paste, copy and paste, copy and paste. That's it. One input, many outputs. Copy column transformation. It is used to create a copy of a given input column, performing new operations on new column. Multicast creates multiple copies of a whole data, whereas copy column creates a copy of a given column. Clear? So what is the meaning of a copy column? For example, I have some data here. So employee ID, then employee name, then employee salary. Okay. So I'm getting some data. One John 100, two say Raj 200. So this data I'm going to take it to the destination. I copied. After copying, I would like to create a copy of a new column. So this column data I would like to copy, create a new cell. So and I copy the same data is going to come here. I'm going to be copying this data. So the salary column data I'm going to be copying and making as a new column. So now the new salary I'm going to be updating here. The new salary for this guy is this much. So when I do like this, what is the advantage? When I copy only one column data and do some kind of a modifications on this, what is the advantage? I don't lose the existing data. Tomorrow I wanted to understand what is the variance, what is the difference amount between new salary and old salary. If I wanted to get that kind of a KPIs means I can use this transformation. Clear? Copy column is going to be copying a single column data. On that new column, you can do modifications so that the original data is not getting disturbed. So that is the purpose of copy column transformation data. Am I clear? Multicast creates a multiple copies of the whole data. Sometimes you don't need a whole data to be copied. Only one column data I wanted to copy and do some changes there. That is the purpose going for a copy column instead of going for multicast transformation. Now raw files we discussed already. Now audit transformation. This creates the data about environment in which the package runs, name of the package, computer name, operator name, lot of things you can get it into the destinations. SSIS includes system variables to get the above data. This is my source data. Whenever I am dumping the data to the destination, I am also storing a lot of other information from where I'm getting this data, the computer name, when I have received this data, the date and time, and who's the owner of the package who's executing. Lot of other data also I'm capturing along with the source data. This data is used for the auditing purpose. Tomorrow I wanted to know from which machine I have received this data, from which machine I have received the data. Whether is a trusted machine or a not a trusted machine. So that environment I would like to understand for the auditing purpose. Clear? If somebody is telling me some information from that some server, I can trust it. If I'm getting some data from other servers, I don't want to trust it. So for the auditing purpose, normally we're going to be capturing a lot of other information. So like computer source, computer name, data arrival time, owners, people who are executing your package, those guys names, everything I'm capturing for the auditing purpose. Then we have export column transformation. Then we have import column transformation. Okay, let us understand what is this. I have an employee table, employee ID, employee name, employee photo you can store. Can we store a photo or audio, video in your SQL Server tables? Answer is yes. So you should be able to store your video files, audio files, everything. You have to declare this as a binary data type. Photo is a binary data type. Okay, so this is integer, this is a varchar column, this is a binary. So I have some photos in this format. Now this photos I would like to export with the help of SSIS. This photo will be converting as a JPEG file. The name is john.jpg. Now I have ram photo is available in hexadecimal format or in the binary format, that when I export it, it will become ram.jpg. If I have photos and images that I would like to import, all of them will be converted into a binary or hexadecimal numbers. So export column, import column transformations can be used to work with the photos data, audios data, videos data. If somebody gives you some video files that you can convert into hexadecimal numbers with the help of import column transformation, then you can load into SQL Server table or Oracle table. If you have a lot of photos, when you convert, when you dump these hexadecimal numbers, nobody can understand. So the hexadecimal number will be converted as a JPEG if it is a photo. So now you can give the name to this photo. So john.jpg, ram.jpg. You can work with the video files, audio files, convert them, convert the JPEG files into hexadecimal numbers or the binary data. Binary data you should be able to convert into hexadecimal numbers. Remember, SQL Server cannot store photo as a photo. So if you go to a AdventureWorks database given by Microsoft, okay, let me show you. There is a table called product table, not product, a photo table will be there, I think. Product photo something will be there. Let me show you that. Where is that product photo?
Down, it is down.
Down, is
It
it?
went,
Where is?
went product dot product photo.
Yes, it is there, right? Now production dot product photo. Excellent. So now let me show you this. Select star from the table name. I wanted to store, I want to show you this. Now it is saying invalid object because I'm not pointing to this database. So when I execute, you should be able to get a thumbnail photo. It is hexadecimal number. This number, when you copy into the C drive or D drive, it will become a JPEG file with the help of SSIS package. Now that is what is called export column. This number should not go to the number in the D drive. D drive, if I create employee photos or AdventureWorks photos, I should get the photos, not the hexadecimal numbers. This is hexadecimal number. This is small photo. This is a large photo. Clear? So this is what you need to understand. Clear, guys? And I told you one more thing. So nchar data and varchar data as well, right? So SQL Server is going to be storing different languages data. You go to AdventureWorks. This is a data warehousing database. There is a one table. I have a fact additional international product description table in data warehousing database. Clear? So this database is given by Microsoft, not by me. I did not create. You can download this database from Google and try to restore it. When you execute it, it is giving you different language. Now, what is this language? You can read this language if you wanted to read. Anybody can read Chinese, so you can read. It is telling you it is Chinese Hong Kong. Now this is some other language. Now this is some other language. You see this? So we are able to get lot of data. Now when you come down, so you're having Urdu. So and when you come down, you have Korean language, and even this is my own mother tongue. So this is language given by Microsoft to us. I did not write this language. This is my mother tongue. This is what is our script that we speak in Hyderabad. Okay. So now you can read lot of data is being stored. There's no binary data as it is. You can store. And what is the data type for this product description? If you go check what is the column nvarchar max. Nvarchar max means which is a Unicode data. Unicode means you can store the data as it is. There is no conversion needed. You can have Chinese data, English data, whatever the data you wanted to have it, you should be able to have it like this. Clear? So there is no problem at all. It is not my database. Try to understand. This database is given by Microsoft. Clear, guys? That's what you need to understand. This is our, you know, Hindi. I think we have also Hindi language. It is a national language in India, right? So this is the language most of the crowd in India they read, they speak. Clear? So all these languages are as it is inserted. So like that, you should be able to understand now that tables can store different languages data. Okay, each row can have different language. The data type for this column is that nvarchar or according to us DTWSTR data. Clear? So that is what is the important thing that you should know. Clear? So tomorrow we'll do a beautiful demo on this derived column data conversion. Whatever we have discussed so far today, we're going to be discussing on that. Okay, we'll have a nice demo, complex demo. We're going to be performing tomorrow. Any questions?